Hi, everybody. In this lesson, we are going to look at linear inequalities and what we call feasible regions. So this first section is assumed that you have done linear inequalities before at some point in your algebra classes leading up to this. So these first couple are just a bit of a review, that the solution to a linear inequality consists of all points on the coordinate plane that satisfy that inequality. If you have strict inequality, strictly greater than or less than, you use a dashed line because the line itself is not a solution, but all points on one side or the other are. But if you have non-strict inequalities like greater than or equal to or less than or equal to, then you use a solid line because the line itself is also part of the solution. Once you get your line drawn, you check a test point to decide which side of that line you need to shade. The best way or the easiest way to do these for this course is going to be graphing the lines using the intercepts. So that is just the way, it's not the only way to graph these lines, but it's going to be the easiest way. So what that means is to find 2 points to graph. First let x be 0 and find y, and then let y be 0. Oops, it's hard to write. And find the x. That's just the way that a lot of these are going to be set up, and it will be the fastest way to do it. So if I want to find the intercepts to this first linear inequality, x plus y is greater than or equal to -2. If I first let x be 0, I would get 0 plus y is greater than or equal to -2. And so I get y, if I'm thinking equal to on these to find points, I get y is -2. So one of the intercepts is the point 0, -2. That's the y-intercept. And if I do it the other way, if I let y be 0, then I'm finding the x-intercept. So x plus 0 equals -2. Well, x is also -2. So the point -2, 0 is the x-intercept. Those are the 2 points I'm going to graph. So if I found my intercepts first, so I'm going to graph the point 0, -2, over 0, down -2, and then the point -2, 0, back -2, up and down 0. So those are my 2 intercept points, the point on the x and the y axis where this line crosses. I notice that it is a non-strict inequality, so I'm going to graph this with a solid line. And I'm going to extend this all the way to the end of my coordinate plane. It ends up having a slope of -1 where it's cutting through here at a perfect diagonal. Okay, so there's my line. I've cut this coordinate plane into 2 halves. I've got the upper half and the lower half. And now what we need to do is we need to figure out which side to shade. So this is where you test a point. Use the point 0, 0 as long as it's available. So in this case, 0, 0 is available. That's the center. This point right here is the one we're testing. If it's not available, use something that is almost as easy. The reason we picked this is because 0 is easy. If that's not available, if that point happens to be on your line, then use 1, 1 or 1, 0 or 0, 1, or just try to use something simple. No need to make this more complicated than it needs to be. Okay, so if I test the point 0, 0 in the original inequality, I would be testing 0 plus 0 is greater than or equal to -2. 0 is greater than or equal to -2. That's true. So whenever the test point comes out true, what that means is you shade that side. So we're going to shade the side with 0, 0 on it. That point represents every other point on this side. So if it works, it means every single other point on this side works. So every point over here is a solution. If your test point does not work, then what it means is you need to shade the other side. Okay, let's go ahead and do one more of these examples. So on this one, again, I'm going to find the intercepts for 3x minus y equaling 6 at first. So I'm first going to let x be 0. I get negative y equals 6, so y must be negative 6. 0, negative 6 is my y-intercept. And then if I do 3x minus 0 equals 6, I get 3x equals 6 or x equals 2. So 2, 0 being my x-intercept. I'm going to graph these points. So 0, negative 1, 2, 3, 4, 5, 6 is right here. And the point 2, 0. I notice again on this one I happen to need a solid line. So I've drawn my line, and now I want to test a point. 0, 0 is available, so I'm going to use it to check. If I sub in both zeros, I get 3 times 0 minus 0 less than or equal to 6, 0 less than or equal to 6. That happens to also come out true. So I'm going to shade the side with the 0, 0 on it. It represented every point over here. Again, had that come out non-true, then we would have simply shaded the other side instead.